It is not recommended to leave the unit fused at 40 amps. The manufacturer's instructions specify that the feeder must be fused at 30 amps for a 5 kilowatt resistance grid. The current draw of the resistance grid is approximately 23 amps, which is close to the 30 amp fuse rating specified by the manufacturer. The remaining 10 amps of capacity in the 40 amp breaker does not provide enough margin of safety. In the event of a fault or overload, a 40 amp fuse may not trip quickly enough to prevent damage to the wiring or equipment. Installing a fuse that exceeds the manufacturer's recommended amperage could violate electrical codes and void the warranty on the equipment. An oversized fuse can increase the risk of electrical fires and other hazards. It is recommended to replace the 40 amp breaker with a 30 amp breaker as specified in the manufacturer's instructions. This will ensure that the circuit is properly protected and meets code requirements. Electrical codes, such as those found in the National Electrical Code, or NEC, exist to ensure safety and proper installation. These codes often refer to manufacturer's specifications as a primary guideline for safe operation. Following these guidelines helps prevent electrical hazards. When dealing with electrical circuits, it is important to consider the following key aspects. Firstly, ampacity. This refers to the current carrying capacity of a conductor. The conductors must be sized appropriately for the load they will carry. Secondly, overcurrent protection. This is provided by devices like fuses or circuit breakers, which are designed to protect the circuit from overloads and short circuits. Thirdly, manufacturer's instructions. These provide specific guidance on how to install and operate equipment safely and effectively. In this scenario, the manufacturer's instructions call for a 30 amp fuse or breaker for a 5 kilowatt resistance grid. This recommendation is based on several factors. One factor is the continuous current draw of the resistance heater, which is approximately 23 amps. A 30 amp breaker provides a sufficient safety margin without being oversized. Another factor is the potential for temporary current surges, such as during startup. The 30 amp breaker is designed to handle these surges without tripping unnecessarily. The choice of overcurrent protection is crucial to prevent overheating, fire, and equipment damage. If the breaker is too large, it may not trip quickly enough to protect the circuit in the event of a fault. This can lead to dangerous conditions. Conversely, if the breaker is too small, it may trip frequently under normal operating conditions, causing nuisance outages. Using a breaker that is appropriately sized for the load and in accordance with the manufacturer's instructions is essential for safe and reliable operation. When replacing electrical components or modifying existing circuits, it is important to follow a systematic approach. Firstly, identify the load requirements. Determine the total current draw of all devices that will be connected to the circuit. This information is typically found on the equipment's nameplate or in the manufacturer's specifications. Secondly, select the appropriate conductor size. Use ampacity tables such as those found in the NEC to determine the minimum conductor size required to carry the load current. Be sure to account for any diverting factors that may apply, such as ambient temperature or the number of conductors in a raceway. Thirdly, choose the correct overcurrent protection device. Select a fuse or circuit breaker with an amp rating that is appropriate for the conductor size and the load requirements. Again, consult the manufacturer's instructions and relevant electrical codes to ensure compliance. Fourthly, install the components according to code. Follow all applicable electrical codes and safety guidelines when installing the wiring, overcurrent protection device, and other components. Be sure to make all connections properly and securely. Finally, test the installation. After completing the installation, test the circuit to ensure that it is working properly and that all components are functioning as intended. Use appropriate testing equipment to verify voltage, current, and continuity. In this specific case, replacing the 40 amp breaker with a 30 amp breaker is the correct course of action. The manufacturer's instructions are clear, and following them ensures that the circuit is properly protected. Ignoring these instructions could have serious consequences, including electrical fires and equipment damage. Electrical safety is paramount, and it is important to take all necessary precautions to protect yourself, your property, and others. When in doubt, consult with a qualified electrician who can provide expert guidance and ensure that all electrical work is performed safely and in accordance with applicable codes. Remember that electrical codes and manufacturers' instructions are not arbitrary rules. They are based on sound engineering principles and are designed to prevent electrical hazards. By following these guidelines, you can help to ensure the safety and reliability of your electrical system. The importance of properly sized overcurrent protection cannot be overstated. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect electrical circuits from damage caused by excessive current flow. When a circuit is subjected to an overload or short circuit, the overcurrent protection device trips, interrupting the flow of current and preventing overheating, fire, and equipment damage. If the overcurrent protection device is too large, it may not trip quickly enough to protect the circuit in the event of a fault. This can allow excessive current to flow through the conductors, causing them to overheat and potentially ignite nearby materials. An undersized overcurrent protection device, on the other hand, may trip unnecessarily under normal operating conditions, causing nuisance outages. In order to select the appropriate overcurrent protection device, it is necessary to consider the ampacity of the conductors, the load requirements of the circuit, and the manufacturer's instructions for any equipment connected to the circuit. The ampacity of the conductors is the maximum amount of current that they can safely carry without overheating. This information is typically found in ampacity tables in the NEC. The load requirements of the circuit are the total amount of current that will be drawn by all of the devices connected to the circuit. This information is typically found on the equipment's nameplate or in the manufacturer's specifications. Once the ampacity of the conductors and the load requirements of the circuit are known, the appropriate overcurrent protection device can be selected. The overcurrent protection device should have an amp rating that is no larger than the ampacity of the conductors and no smaller than the load requirements of the circuit. In addition to considering the ampacity of the conductors and the load requirements of the circuit, it is also important to follow the manufacturer's instructions for any equipment connected to the circuit. The manufacturer's instructions may specify a particular type or size of overcurrent protection device that must be used in order to protect the equipment from damage. In the case of the heat pump resistance heater, the manufacturer's instructions specify that a 30 amp breaker should be used for a 5 kilowatt resistance grid. This recommendation is based on the current draw of the resistance heater and the potential for temporary current surges. Using a 40 amp breaker in this application would violate the manufacturer's instructions and could potentially lead to overheating, fire, or equipment damage. Therefore, it is essential to replace the 40 amp breaker with a 30 amp breaker as specified in the manufacturer's instructions. This will ensure that the circuit is properly protected and meets code requirements. The NEC provides specific guidelines for overcurrent protection in Article 240. These guidelines cover various aspects, including the selection, installation, and protection of overcurrent devices. According to NEC 240.4, conductors must be protected against overcurrent in accordance with their ampacities. This means that the overcurrent protection device must be sized to protect the conductors from overheating due to excessive current flow. The NEC also provides specific rules for sizing overcurrent protection devices for different types of loads, such as motors, appliances, and lighting. These rules take into account the starting currents, intermittent operation, and other characteristics of these loads. In addition to the NEC, local electrical codes may also have specific requirements for overcurrent protection. It is important to consult with a qualified electrician or local electrical inspector to ensure that all applicable codes are followed. The use of appropriately sized overcurrent protection devices is essential for electrical safety. By following the NEC local electrical codes and manufacturer's instructions, you can help to ensure that your electrical circuits are properly protected from overloads, short circuits, and other electrical hazards. A properly sized overcurrent protection can lead to serious consequences, including electrical fires, equipment damage, and even personal injury. Therefore, it is important to take the time to select and install the correct overcurrent protection devices for your electrical circuits. In summary, when dealing with electrical installations and modifications, adherence to manufacturer's specifications and relevant electrical codes is paramount. The manufacturer's recommendation to use a 30 amp breaker for a 5 kilowatt resistance heater is not arbitrary, but is based on the electrical characteristics of the heater and the need for adequate overcurrent protection. Installing a 40 amp breaker in this scenario would violate the manufacturer's instructions and could compromise the safety of the electrical system. Therefore, it is essential to replace the 40 amp breaker with a 30 amp breaker to ensure code compliance and prevent potential electrical hazards. Remember that electrical safety is a shared responsibility, and it is important to take all necessary precautions to protect yourself, your property, and others from the dangers of electricity. When in doubt, consult with a qualified electrician who can provide expert guidance and ensure that all electrical work is performed safely and in accordance with applicable codes.